Students, here we will study fourth unit of your syllabus of the paper Applied Science. The unit is Units and Measurements. We know that physics is a science based upon measurements. These measurements should be exact measurements. So, for a student, it becomes important to become familiar with various methods of measurements and units in which these measurements are expressed. These measurements are basically a means of communication. For scientists, these will be used for understanding the phenomena. For society, this can be the means of communication for the quantities. By engineers, it is useful for practical aims. All quantities which are observed, measured, must be clearly defined. There should not be any doubt in the measurement. For example, if I say 1 meter of something, it should mean the same length all over the world. Otherwise, there would be endless confusion. Every measurement, if it is a distance, time, a weight, it will require two things. It consists of a number and unit. The quantity is measured by comparing it with some standard to find how many times the quantity is greater than the standard. So, for example, 1 feet is standard of length when we will measure something that can be the width of a table, right, or the length of a cloth. So, we will measure it how many times it is of 1 feet, so that we can say that the width of the table is a 5 feet, 3 feet, etc. The standard is called as the unit in which the quantity is measured. So in this example, feet is the unit of length here. A unit is a standard value in terms of which the other quantities are expressed. And the number showing how many times as great is called as the major number. So in the same example, if the width of the table is 5 feet, then feet is a standard unit and 5 is a major number. So, how should be a unit? We are using it as a standard for measurement. So, obviously, it should be independent of physical definition. So, if I mean 1 kilogram of something, that 1 kilogram should be same for all over the world. If I say 1 meter, it should mean the same length all over the world. A standard or a unit should be such that it must be possible to define it unambiguously. It must be easy to reproduce. Means, if I want to measure the length, I should get that standard 1 feet easily. If I want to measure the weight, I should get that 1 kilogram easily. It must be invariable with a time and place, obviously. It must be possible to multiply or divide each one of the standard or unit. Now, we want to see what is meant by fundamental quantities. Fundamental quantities. We will list out few of the quantities what we use, those we use in physics. Mass, volume, distance, time, acceleration, density, and so on. Now, what is mass? Mass is a quantity of matter. Is it possible to express in other physical quantity? No, we don't find. Mass can be expressed as a mass only, right? So, it is a fundamental quantity. Volume. What is volume? Length into breadth into thickness. So it is distance into distance into distance. Volume is expressed as a multiplication of length into length into length. It is not a fundamental quantity. It is not a fundamental quantity. So what is a fundamental quantity involved here? Is a distance. Distance is fundamental quantity. Distance is a fundamental quantity because volume is expressed as length into length into length, or that is distance into distance into distance. Volume is expressed in terms of distance. Is it possible to express distance in some other physical quantity? No. So it is a fundamental quantity. Density. Is it a fundamental quantity? No, because density is equal to mass upon volume. It is involving two physical quantities, mass and distance. So it is not a fundamental quantity. Not a fundamental quantity. Velocity. Velocity is distance upon time. Distance upon time. It is involving two quantities, distance and time. So it is not a fundamental quantity. It is not a fundamental quantity. But time. We cannot express time in terms of any other physical quantity. So time is a fundamental quantity. So, in science, we come across large number of unrelated quantities and hence large number of units are required to represent these quantities. There are large number of physical quantities. Length, mass, time, distance, volume, velocity, acceleration, pressure, and so many all. But it is possible to express all physical quantities in terms of only three basic quantities. Three basic quantities which cannot be expressed in any other physical quantities. They are separate, distinct units, independent units. These are called as fundamental quantities. So, in mechanics, what are these fundamental quantities? Length, mass, and time. Do you find length can be expressed in terms of mass or something else? No. In the same way, mass and time are also fundamental quantities. Other physical quantities can be expressed in these three physical quantities. So these are the basic quantities. These are called as fundamental quantities. These quantities cannot be expressed in terms of any other fundamental quantity. All other quantities in mechanics can be expressed in terms of these fundamental quantities, like density is mass upon volume, like velocity, distance upon time, and so on. A fundamental quantity is a quantity which cannot be expressed in terms of any other physical quantity. The units in which these quantities are measured are called as fundamental units. And the quantities which are not fundamental quantities, these are related in some manner to fundamental quantities. So, these quantities can be expressed in terms of basic quantities, fundamental quantities, which are mass, length, and time. These are called derived quantities, and units in which these are measured are called derived units. What are the examples? What are the examples? Like area, length into breadth. Like volume is equal to length into breadth into height or thickness. So area or volume, they are depending on length. Let us take other example as velocity. How you calculate velocity? It is distance upon time. It is distance upon time. It is length upon time. Acceleration. How do we calculate acceleration? Change in the velocity divided by time. Change in velocity divided by time. So, acceleration will depend upon how many quantities here. Velocity upon time, it is in units. It is depending on it depends on velocity and time. In turn, velocity depends upon distance upon time. and further again upon time. So acceleration will be in all overall net. It will be distance upon time square. So these are examples of derived quantities. These are three systems of units which are used for measurements of physical quantities since long time. French system or CGS system, which has units of centimeter for length, gram for mass, second for time. FPS system, which is also known as British system, has the unit of foot for length, pound for mass, second for time. MKS system has the units of meter, kilogram and second for length, mass and time respectively. Above all, the latest version of metric system is International System of SI Units. It is used all over the world. This system consists of 7 fundamental units and 2 supplementary units, with which we can derive units for all possible quantities of science and engineering. This system has distinct edge over all other metric systems because it is comprehensive, coherent and rational. Hardly there is any discipline where this SI system, which this SI system does not cover. The meaning is with the help of this system, International System of Units, it is possible to cover all disciplines. The table shows the 7 base SI units of base fundamental quantities and their symbols. For example, length, the unit is meter, mass, the unit is kilogram, temperature, the unit is Kelvin, time, the unit is second, amount of substance, the unit is a mole. For luminous intensity, the unit is candela. For electric current, the unit is ampere. This figure shows supplementary units for SI systems. Plane angle and solid angle. Plane angle. What is a plane angle? The angle subtended by the arc of this circle. This ds is the arc of a circle. The angle subtended by this arc of a circle at the center O of the circle. So what is that angle? Arc ds subtends an angle d theta at the center. This is plane angle. Plane angle measured in radians. So what is it given by? D theta is equal to arc ds upon radius r radian. D theta is equal to ds upon r radian. So what is the unit of plane angle in SI system? It is radian. Solid angle is nothing but 3D analog of d theta. So if the circle subtends an angle d theta at the center O, what is solid angle? The area dA of a sphere subtends an angle d omega at the center. This d omega is the solid angle which this area dA of a sphere, it is subtending at the center O of the sphere. It is given by d omega equal to dA upon r square. D omega is equal to dA upon r square steradians. The unit of solid angle is steradians. A sphere of radius r. A sphere of radius r, complete a sphere. What is the surface area of a sphere? It is 4 pi r square. So what a complete sphere subtends an angle at the center, it is given by dA will be replaced by 4 pi r square upon r square. So a complete sphere subtends an angle of 4 pi steradians at the center. That's about supplementary units. Those are plane angle and solid angle, d theta and d omega. So students, in this lecture we have talked about measurements of physical quantities. We have seen which are fundamental quantities, derived quantities, fundamental units, derived units, systems of measurements, that is CGS, MKS, SI, FPS systems of measurements. We have seen supplementary units for SI systems. Those are plane angle and solid angle. Thank you, dear students.